All right, so this is the densities of solids and liquids lab. Here are some of the components, some of the glassware and the unknowns we'll be using. So during this lab, I'm going to just run through the procedure. I'll explain things as I go, but I'm not going to explain it in detail because you have the procedure to see the details. I'll mention the different data points that you'll have, the data that you need to put into your report sheet, but I'm not going to tell you where to put it in the report sheet because you have that. So you should be able to take the information I give you and put it into the report sheet and then do the proper calculations. So let's get started. All right, so we're going to weigh a 10 ml graduated cylinder in here. And there's the mass. Close the door here. Let it settle in. All right. All right, so we're going to be using the volumetric pipette to fill the graduated cylinder with 10 mils of water. So the volumetric pipette and the pipette filler here. So we get this long range view, but you can see, hopefully, let's see, that's 10 mil. Yeah. And then see that line here, that's what we're going to fill to. And at that line, it's 10.00 mils. So when you put in this value, it's 10.00. So very precise. And we're going to fill up the graduated cylinder. So you do, and pipette filler, we just dial it up. Water fills up, goes in the bulb here. Keep dialing up, and it should get. If it's leaky, if it's not sealed right, it won't go all the way up. This one looks like it's good. Get to that 10 mil mark, and then transfer it over, and just press the trigger here on the side, and that'll release the water. Not all the water will go in, but that's accounted for. The last drop there is accounted for. It doesn't have to go in. And that is done. And now I'll bring the camera over so you can measure that better. You can see that it's slightly above the 10 mil mark, and that's because this graduated cylinder, as precise as it is not as good as the volumetric pipette, which it goes out to the hundredths place for the mils. So for this one, if you put in this value, you'd have to estimate, but it'd be something along the line of 10.1 mils. Okay. Weigh this out. This is the graduated cylinder and the water. Okay, I'm going to take the temperature of the water and come in tight here and see what we see. And here's our unknown liquid 11. Okay, the measuring of the small, clean, dry beaker. I'm going to pipette 10 mils of the unknown liquid into the beaker. And since I've done the pipette in the long view so you can see what's happening, it's a long device here. Come on. I'll just do it this way, close up. Get to 10 mils. And then transfer it here. And this is 10 mils of the unknown liquid. Like so. Okay, and here is the weighing of the beaker with the 10 mils of the unknown liquid. All right, here's the regularly shaped object, a cylinder. This is cylinder 49. Okay, and I'm going to weigh the irregularly shaped object, and the 0 or tare button makes it 0, so that weighing boat is no longer being weighed, so whatever we put in it, that should be the mass of the regularly shaped object. Now we're going to find the dimensions of this. And we're going to use this, the calipers here, get it back to 0. And this measurement is in millimeters. So first thing, I'm going to measure the length of it. You can use a ruler, of course, but since we got these. And it says 51.05 millimeters. And then for the diameter, we need the radius, but we'll find the diameter and then divide by 2. Let me get back to 0 here. This is sticking a little bit. Just make sure it is at 0, and then I'm going to pull this back. And the diameter is 9.53 millimeters. So the radius of this object is going to be half that. So just remember that what we found here is the diameter, but what you'll need is the radius. All right, now we're going to find the volume of the regularly shaped object using water displacement. Doesn't quite look it, but if you look at the, I got this on a stand now, the camera, but this is set at 5.00 mils, and we're going to put this guy into the flask, or in the graduated cylinder. But you don't want to just drop this in. You want to make sure that it goes in slowly, carefully here. What's that sticker that was getting in the way? Okay. And now I think you can see it pretty clearly here. Oh, if I get my finger out. Okay. So you can estimate the value there. There we go. And now for the irregularly shaped objects. Here, there's a bunch of them in this container. This is the unknown 3. So it would be hard to measure the dimensions using a ruler for these, so we're going to do it by water. We're going to find the volume of them by water displacement, but first we're going to have to put them on a balance. We're going to use them all. You don't want to just use one. You want to use all of them that are available. The more you have, the better, or the more accurate your reading is going to be for the density when you're done. Okay, so I'm going to put a weighing boat on here, and we're going to 0 or tare weighing boat, and then put so it's going to jump around because I have that door open there, but I think that's, make sure first here. Yeah, so just the air currents, they can change it because we're talking about 1,000th of a gram there, so they can have an effect. So that is the mass of all of those particles, those pieces there. Okay, now we want to find the volume of all of these guys here, so we're going to put them into the graduated cylinder. I have a 50 mil graduated cylinder here because this looks like there's going to be quite a few of them. I have the water at 20 mils. I'm going to put all of these guys in here, if you can see what I'm doing. It's a little, oops, it's easier. Okay, so all of them have gone in, and you can register what you think that volume is.